Hey everyone, today we are going to be graphing exponential functions with transformations. So here I got this crazy little guy, this exponential function, right? It's filled with lots of transformations, and don't worry, it may seem intimidating, but I got these steps that I always use for these types of graphs, and I think that will help you. Okay, so let's begin. So first of all, we have 2 to the 1/2 bracket x minus 4 bracket square bracket plus 1. Okay, so let's do the first step. First step is identify the parent function. Alright, the parent function is, an exponential is really b to the x, right? The base. What is the base in this case? Well, it's a 2. So we know it's a 2, and x remains the same because, well, x is there. And we want to plug in values for x. So the parent function is 2x. Well, next step. Number 2, make a table of values for this basic graph. So, let's do that. Alright, I'm going to start with I'll stop there. Maybe I'll do it, okay. Yeah. Alright, let's start plugging in. So if we plug in a -2 for x, 2 to the -2, if you know your exponents, 2 to the -2, it's the same thing as 1, 2 squared, because we want to get rid of that negative. To get rid of the negative, basically just put it under a 1 and leave that number though. And if you evaluate that, you get 1/4, right? Same thing if we plug in a negative. 2 to the -1, I'll do it. We want to get rid of that negative, so you do this, which is 1/2. Alright? 2 to the 0th power, anything to the 0th power is 1. Just remember that. 2 to the first power is 2, 2 squared is 4, 2 to the third is 8. Great. Okay, I need the space, so. Whoa. Sorry, guys. Yeah, so now we can move easily to our next step, which is identify what will occur to the x's and the y's. That's the first part. So let's just analyze what is happening. What is the difference between this and this? What's going on? Right? What is changing this to make it look so fancy like? Alright, let's see. So remember, everything inside the bracket right there, right here, right there, just that, is applied to the x's. They changed this part of the table, the x values, yeah, domain. So what is going on? Well, remember, everything inside the bracket, everything. You know the phrase, everything is not what it seems, or something like that? Yeah, everything, I don't know. But it really is the case for numbers inside the bracket. Not really numbers, the operations that they seem to apply. So x minus 4, you might be thinking, well, you are subtracting 4. No, you're not actually. What you're doing is the opposite. Always think opposite inside the brackets. -4? Nope, what's the opposite of subtracting? Well, it's adding. So you are adding 4. I'm just going to make these, you'll see why. It's the y. You are adding 4 to the x's, okay? That's one of the things you're doing. What about this 1/2? Okay, think opposite. This is, well, you can do two things. So here you got, it looks like a multiplication, right? It looks like you just multiply by 1/2. What's the opposite of multiplication? What's division? So technically you could divide by 1/2. That's how you would actually do it. But an easier way is to just multiply, but don't multiply this. Multiply the reciprocal. Okay, whatever. The reciprocal of this number. So we are really multiplying by, what's the reciprocal of 1/2? Put that there. Well, it's 2. It's 2. Okay? So we are adding 4 and multiplying by 2 to our x's. What about our y's? Well, in this case, y is very easy. Y is everything outside the bracket, which is just the 1 here. The 2 is the base, so it's not, the 1 right here. So we are just adding 1 to our y. Now let's do the second part of this step. Apply the transformations to the basic graph. Well, what's our basic graph? Our basic graph is our parent graph, the parent function, 2x. How do we apply it? Well, let's see. So we said to our x's, we are multiplying by 2, right? Multiplying by the reciprocal and adding 4. Correct? To our y's, we just said we are adding 1. Alrighty? Okay. And now comes the easiest part. You just have to apply this arithmetic to each value in the x's, and here to each value. You're just really distributing. You're adding 1, here you're multiplying by 2 and adding 4. Okay, let's do it. So what's negative 2 times 2? Well, it's negative 4. Negative 4 plus 4 is 0. Negative 1 times 2, that's negative 2. Negative 2 plus 4, 2. 0 times 2 is 0. 0 plus 4, 4. 2 times 2 is 4. 4 plus 4 is 8. Oh, I think did I do something? I think I did. So I did negative 1, yeah. Yeah. I think I skipped 0. 0 times 2, or didn't I? 0 times 2 is 0 plus 4 is 4. Oh, I skipped a 1, I think. 1 times 2 is 2. 2 plus 4 is 6. Okay? 2 times 2 is 4. 4 plus 4 is 8. 3 times 2 is 6. 6 plus 4 is 10. Okay? Same thing here. That's all you're doing. 1/4 plus 1, right? That's what you're doing, is 5/4. Or 1.25. What's the next thing? Oh, 1/2 plus 1, that's 3/2. Or 1.5. Okay? 1 plus 1, well, that's 2. 2 plus 1 is 3. I know it's like that. 4 plus 1 is 5. 8 plus 1 is 9. Okay? Now it's just plot new points and graph. Now before I graph, I want to talk about this 1 value right here. This value, you can call it Q or K or whatever it's called in your country or your school, but I usually call it a Q. This value is called your horizontal asymptote. An asymptote looks like this. It's a dotted line on a graph where the graph can never go through or even touch. Okay? So you might look, a basic 2x function, 2x, 2 to the x, if you know that, you should, it looks like this. And you can see it never crosses like that. It's always above 0, right? So it's just tangent to the 0, because the horizontal asymptote here is 0. Here, because 2 to the x, you're really adding 0, right? That's why. Here you're adding 1. This value is always your horizontal asymptote. You have to mark this value before you start graphing like this. So your graph will look like this. And you will see that right now because we have this function. Okay? So we know that our horizontal asymptote is 1. Right? It's this value. So I already did this before. I forgot to erase it. So I can do it with you, but it's okay. I think that's why I wanted to explain it. This is 1. Okay, let's start graphing. Okay, sorry, bad tick marks. Our first one is 0, 1.25. So 0, 1.25. Now I'm gonna graph with them. Oh jeez. 0, 1.25. No, that's a half. Somewhere there. Next one is 2, 1.5. 2 and 1.5. 2 and 1.5. Okay? Next is 4, 2. 1, 2, 3, 4. 1, 2. 6, 3. 4, 5, 6. 3. 8, 5. So 6, 7, 8. 5. Yep, and 10, 9. 8, 9, 10. I'm not even counting, but I'm supposing 9 looks some around here. So as you can see, it's slowly going up and becoming very steep. So if we connect this, we'll have something looking like that. And this line will actually, as you can see, it's never touching. I got, look at these values. I got 1.25, 1.5, and next one you're gonna get very small numbers, and they will never touch 1. So you will have a graph looking. Okay, I just literally touched it. You have to excuse. Yeah, you know what I mean. It's just not gonna pass that line. It's never gonna legitimately get to 1. It's gonna be 1.000 blah 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 blah. Never 1. Okay, so there's our graph, guys. As opposed to 2x, where 2x looks like this, something like that. So this, I should have used a different color. And this 2 to the la 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 plus 1. La la. Okay, guys. I hope I helped you. Just try to remember these, like this one, and this one. You can memorize this in your head. These 2 steps. Just parent function and make a table of values. This is where it gets tricky, but just really analyze what's happening. Look at this, and look at your function right here. And see what's going on. Use the reciprocal to multiply inside the bracket, and it's whatever is plus or minus, it's the opposite. So if it's plus 4, plus 2, it's minus 2, minus 4. Minus 4, we did plus 4. And this value right here is your horizontal asymptote. But you also have to apply this to the y's, like we did here. We added 1. So I hope I helped you guys, and I will see you in my next video. Thank you.